We are going to discuss the derivatives of exponential and logarithmic functions. So derivatives, the formulas are given. D by dx, the derivative will be ex, and log bx means by base is b and this x. So the derivative of this will be 1 upon x. But see some important algebra of logarithmic functions, so that you can just have a look. Log this ap can be written as log bp upon log ba. If you choose any other base, writing that you want to change base this a, so you can write this log bp and log ba, and this log b p cube. So this is your log b mod p plus log b and mod q, and this log b p n, the exponent is n, so that can be written as n log b and modulus this p. And you should always remember that the logarithmic functions are defined for all positive values of x. And now this log b x upon y can be written as log b mod x minus log b mod y. See, this mod I am putting in every rule, because this functions are not defined if x is negative. So you have to mention that mod x or mod y, something like this. But here if you see in case that x is negative, y is negative, then this quotient will be positive. But if you want to write them separately, then x and y cannot be negative. So keep in mind this mode value, writing this mode is very important. Now this d by dx, this is derivative of exponential function is ex, and logarithm function is 1 upon x. So now we use these basic concept and we solve these problems in which we have to find dy by dx. So let this is y this, so I'm writing this differentiate with respect to x. So when you differentiate with respect to x, you have to apply that quotient rule, dy by dx. So apply that quotient rule. This is sine x whole square, sine x as it is, and dy by dx ex minus ex dy by dx sine x. So you can apply this formula, or you can write that answer directly also. This is sine x, and derivative of ex is ex, and this is ex, and derivative of sine x is cos x upon this is sine x whole square. So you can take ex common. So if you take ex common, then it will be ex bracket this is sine x minus cos x upon this is sine x whole square. So you can leave this answer in this form. Now see this part number 3, why I just you may leave for the time being, because you need to know sine inverse x, then you can solve this. So now we are coming to question number 3. So 3 is y equal to ex cube. You can see this is the composition of two functions, first exponential function and second is this x cube. So we differentiate with respect to x and we'll apply the chain rule. So this will be dy by dx, and first you apply this ex cube. So ex cube will be ex cube. First you differentiate the exponential function, and into chain rule you can see that x cube has to be differentiated. So x cube differentiation will be 3x square. So you can this is the final answer, and this is how you can differentiate the exponential function when it comes in as a composition of two functions. Okay, these are some few more questions from exercise 5.4. So you see this first question, y equals to log and cos ex. So we differentiate with respect to x, so it will be dy by dx. So now you can see this is again the composition of three functions. First function is log, second function is cos, and third function is ex. So we'll apply the chain rule. So according to chain rule, so log this is cos x. So but you always remember that this cos ex will be positive. So this is 1 upon cos ex. Next you differentiate cos this cos. So cos will be this minus sine, and ex will remain as it is, and third function is ex, so it will be ex. So this is how you can write the answer. You can simplify further. This is sine upon cos. So this can be written as minus 10 ex, and this ex you can write here into this ex. Now come to this. This is your question number 6 of the same exercise 5.4. So we differentiate, then we will write dy by dx. Ex derivative will be ex, and this ex square, this is again a chain rule. First you do the differentiation of ex square, and x square derivative will be 2x, and similarly it keep going on. This 3x square ex cube and plus delta dash, you can write that 5x4 and this ex5. So this you may this way you can write the answer. You cannot simplify it further, so better you leave the answer here only. Now consider this seventh one. This is square root square root x. So please understand there are actually three functions, and this is the composition of that three functions. First function is your root, second function is exponential, and third function is again root x. So we have to apply this chain rule, and will differentiate using the chain rule, differentiate with respect to x. So this will be dy by dx, and first you apply this chain rule. You must know that derivative of d by dx root x is 1 upon 2 root x. This has come using the power rule. So you apply this becomes 1 upon 2, and whatever is inside the root, it will be coming there, e root x. So first square root we have differentiated into, then e. Second function is exponential, so e root x, it will be e root x. Then root x is the third function, so derivative of that will be 2 root x. So this is that you can write it finally, or little bit simplification you can do on your own. Like this will be 1 by 4, this root x, and this you have to write, this is e root x 1 by 2, and this is e, this you can take this as 1. So 1 by 2 minus 1 if you do, then it becomes e root x, and this will be, this is root x, so you can write that as in one root only, this is root x. So this you can write in the simplest form. Now come to this is 8th part, y equal to cos log plus ex. So again we'll be differentiating, this is the chain rule, differentiate with respect to x. So dy by dx, this will be cos, you see the first is cos this sign, and inside this bracket will remain as it is, into log x. It's already given that x greater than 0, so you have no need to mention anything, or you no need to write as 1 upon mod x something. So x is already positive, because x cannot be negative, because log x is always defined for positive numbers. So now this will be 1 upon x, and this ex derivative will be ex. So that is your final answer. Now we'll see exercise 5.5. This exercise is the special one, because in this exercise you will be using logarithmic functions, and without using logarithmic functions these exercises will be very difficult to solve. But if we use logarithmic functions, then this will become very easy to solve. So you see this first question, in this first question we have to find the derivative of this function, and this can be done in two ways. First way is that you apply the product rule for three functions, and that product rule of three functions, I can write this u v w first derivative. If you want to find with the help of this, then u v w dash plus u w v dash plus u dash v w. So this is the rule for the product of three function, but that is going to be very difficult, and I will not suggest to use this product of three functions. You can use in this particular question, this is because this question is easy, but for rest of the questions you have to apply the logarithmic functions rule. So logarithmic functions rule, I am writing the rule here. If log ab, or you say log abc, then this becomes log a plus log b plus log c, and I am assuming that all abc are positive. So a b c are all positive. So I am assuming this thing, and I want to apply this logarithmic formula in this question. So we'll write this, taking log both side. So this will become log y, this will become log cos x into cos 2x into cos 3x. And now we'll open this with the help of this formula, and this can be written as log cos x plus log cos 2x plus log cos 3x, and this is log y. So in all these we are assuming that this cos x is positive, this cos 2x is positive, cos 3x is positive, because you should remember one thing, that log x, the function is defined for only positive values of x. So now we differentiate with respect to x. Now you can see this is not the simple function, this is the composition of functions. So you have to apply, this is first, this is log 1 upon y, and then for y it will be dy by dx, and this log cos x, it will be cos x, and cos x derivative is minus sin x, plus log cos x is 1 upon cos 2x, and cos 2x is minus sin 2x, and 2x is 2. So I am applying chain rule. This cos 3x is 1 upon cos 3x, and this will be minus sin 3x, and for 3 it will be 3. So now you can simplify this. We can write dy by dx as you do the cross multiplication y. So this will become your minus 10x, and this will become minus 2 10 2x, and this will become minus 3 10 3x. And finally you substitute the value of y that you got in the beginning. So y is your cos x, cos 2x, and cos 3x, or you can write this minus 10x minus 2 10 2x minus 3 10 3x. This can be simplified further. If you take LCM, then you can simplify it further, but it is okay if you leave up to this. Now you see this question number 2. This is y equal to square root x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5, and this can further be written as x minus 1 x minus 2 x minus 3 x minus 4 x minus 5, and the whole is one exponent as 1 by 2. You see this rule, if log, you can see xn, then it becomes n comes here, and this becomes log mod x. So we are going to apply this here. So if I take log both sides, then it will be log y, and this 1 by 2 will come here, and this will be log x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5. Now we have one more rule of quotient, that is log x upon y. This becomes log x minus log y. So that is the another rule of log x upon y. So you can apply this log x upon y formula here. So it becomes, this is 1 by 2. So I am putting this bracket, this is log x minus 1 x minus 2 and minus log x minus 3 x minus 4 x minus 5. Here it is nothing mentioned regarding the what is x, it is greater than 5 or it is greater than 1, whatever it is. So we are assuming that all x minus 1 x minus 2 x minus 3 x minus 4 x minus 5 are greater than 0. So we are taking them as positive, but if in case you have any doubt, you will put the modulus sign. Now further we can apply another rule, which is the product rule, log a b c. So log a plus log b plus log c. So it can further be written as log x minus 1 plus log x minus 2, and this will be log x plus x minus 3 plus log x minus 4 plus log x minus 5, but because minus is outside, so we'll make them negative. This is log x minus 3 minus log x minus 4 minus log x minus 5. So this way we have opened this. Now we simply differentiate with respect to y. So differentiate with respect to x. Now you see that what comes. So this will be 1 upon y and dy by dx, and this will be 1 by 2, this is constant, will remain outside, and this will become 1 upon x minus 1. This is, if you apply if you differentiate x minus 1, this will be 1, so I'm not writing 1, otherwise 1 will come. Here it is 1 upon x minus 2, differentiation of this, so it is again 1, and for this 1 upon x minus 3, for this 1 upon x minus 4, and for this 1 upon x minus 5. So now we are not going to take LCM, otherwise this will be very difficult. So our final answer will be dy by dx y, this is 1 by 2, and we can write this 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5, and that value of y you will replace from this. So if you write this y value of y here, then it will be the complete answer. Now you can see that we have y equal to log x and exponent as cos x. Whenever you get functions, exponent in as a functions rather than a power. So whenever you get functions exponent as function, you have to apply logarithmic formulas. So here I take log on both sides, so that will be log y, and this will be log x, and this is cos x. So this is the exponent, so it will come here, this will become cos x log, and this is log x, this is log y. Now you can see this is the product of two function, whereas this second function we have to apply the chain rule. So we now just apply the product rule first, and then we'll apply the chain rule. So we'll write differentiate with respect to x. So it becomes 1 upon y dy by dx. This will be equal to cos x. You take cos x as it is. Then log, if you differentiate this. So first one is that you differentiate log. So log, this will become log x, because this will come in the denominator, into log x, the derivative of this will be x, and plus, so this you have differentiated. Now take log x as it is and differentiate cos. So cos differentiation is minus sin x. So now your answer has come. So you can write that dy by dx equal to, this is y, and you can put the bracket, this is cos x and x into 1 upon log x, and this is plus log x, and you can write this minus sin x, and finally just you have to substitute the value of this y was log x, and this is cos x, and bracket you can write this cos x upon x log x minus log x, and this is sin x. So this is your final answer, minus log, this minus has been shifted here, so it becomes minus. Now this is the another type of questions that we can we are facing now. These type of varieties are to be solved in some other way. So what we do in these questions, we assume let u equal to x is to power x, and we take v as 2 sin x. Now after taking this u and v, the function will become, you can see that y will be u minus v, and now we'll find we mark this as 1, and first we find the du upon dx. You see how we find du upon dx. We'll again take log both side, taking so this becomes log u, and this becomes log x, exponent as x. So at x will be bringing here x, and this is log u. You keep in mind always that x, we are assuming that it is positive, but because if I don't assume, then I have to use mode. So now I can differentiate with respect to x. So 1 upon u du upon dx, and this will be, you apply the product rule. So first you take x as it is, then derivative of log x is x, 1 upon x, and then take log x and derivative of x will be 1. So you get du upon dx as you can cross multiply u also, and u is your x is to power x, and this is 1, and this is log x. So we have found the value of du upon dx. Now next we'll find the value of dv upon dx. So again we have to take the log both side. So I'm taking log both side. Log v will be, then sine is in the power, so sine x, and this will be log 2. And now remember this, that log 2 is constant, so do not treat it as a function. So when I differentiate, then it will be 1 upon v dv upon dx. I am differentiating with respect to x, and then sin x becomes cos x, and that log 2 is a constant, so it will remain as it is. We are not going to touch this log 2. Now we have to see from 1 we have y equal to u minus v. So we again here differentiate with respect to x, so it becomes dy upon dx equal to du upon dx minus dv upon dx. So you have to just substitute the value of du upon dx and dv upon dx. So my dy upon dx will become, you can see that du upon dx is x, and this is 1 plus log x, and dv upon dx is cos x log 2. So this is my final answer. And you see this type of questions when you can see that functions, exponent as functions, and there are more than 2 functions with plus sign or minus sign can be there.